Good evening, everyone. Myself Gautam Sharma. I welcome you all in Sapience Education. So today I am going to solve question number 10.7 of chapter oscillations. So let us do this. In question number 13.7, the motion of the particle executing a simple harmonic motion is described by the displacement function as this. If its initial condition is time at a time t is equal to 0, the position of the particle is 1 centimeter and its initial velocity is omega centimeter per second. What are the amplitude and initial phase angle? So what they have given as per the question they have given, the equation that is x at a time t is equal to a cos omega t plus phi. Now at a time t is equal to 0, the particle displacement that is x is equal to 1 centimeter. Also at a time t is equal to 0, the velocity is how much? Velocity is omega. So we need to use this condition so that we can get the value of amplitude, initial phase angle, angular frequency of the particle is pi second. So they have also given angular frequency of the particle as a pi second. Now let us put the values here of at x is x at x at t is equal to sorry at x at a t is equal to 0 is a cos 0 plus phi, and this is equal to 1. A cos phi is equal to 1. This is one equation. And so velocity is equal to dx by dt. This is equal to a omega minus sine omega t plus phi. Now velocity at a time t is equal to 0 as per the question given condition is equal to omega, and this is equal to a omega sine, put the value of time t is equal to 0, so this will be 0 plus phi. So from here sine phi is equal to a sine phi is equal to 1. But this won't be the 1 because this is minus 1, so this will come as a negative. So squaring 1 and 2 and add. So if we square 1 and 2 equation and add, so this will be a square sine square phi plus b is plus a square cos square phi, and this will be equal to 1 square plus 1 square, so this is 2. So if a square is common, so finally a square will be 2. So from here we will get a as a root. So we have got the value of a as an amplitude. Now it is a time to find the initial phase angle. So divide equation 2 by 1. Divide equation 2 by 1. We will get tan phi is equal to minus 1. So this will be only possible when the value will be minus pi by 4 or 3 pi by 4, minus 3 pi by 4. So if if you go through this, so this won't be applicable minus 3 by 4, because if you put the value, so it won't satisfy the equation. So finally, the value of phase angle is how much? So the value of phase angle is minus pi by 4 or minus pi by 4 plus 2 pi. So this will be 7 pi by 4. So if you want to draw the condition, so you can see here. This is the condition. So from here, this will be 7 pi by 4, or from here it will be minus pi by 4. So I hope you have understood this. Okay. Now the same question they are asking, that if instead of a cosine function we choose sine function to describe the S.H.M, what are the amplitude and initial phase of the particle with the above condition? So let us consider, they have given x is equal to b sine omega t plus alpha. Now the initial conditions are same. So at x at a time t is equal to 0, this is equal to 1, and this is equal to b sine alpha. Why? Because if you put the value of time t is equal to 0, so we will get b alpha. So this is equation 1. Now velocity. So velocity at a time t is equal to 0. So first of all, we need to find the velocity. So what will be the velocity? So we should differentiate the above equation. So we will get the velocity. So we can get the velocity as b sine b omega b omega cos omega t plus alpha. So put value b at a time t is equal to 0. So this will be equal to b at a time t is equal to 0. We have a value omega as an initial condition, and this will be equal to b omega cos alpha. So we have got cos alpha. So cos alpha is omega got cut down. So b cos alpha is equal to 1. A sine, not a, it is b sine alpha is equal to also 1. So this is equation 2. This is equation 1. So squaring and adding both the equation, we will get b square is equal to b square sine square alpha plus cos square alpha, and this is equal to 2. So from here, b is equal to plus minus root under 2, or we can put here any value of either plus or minus. Now it is a turn to find a phase angle. So divide equation 1 by 2. So what we will get? Tan alpha is equal to 1. So alpha is equal to pi by 4, or pi by 4 plus 2 pi, pi by 4 plus 2 pi. So this will be 9 pi by 2. So the only difference was that they have a value minus pi by 4. Initial condition, that is cos condition. Initial condition, we can't say initial condition. The earlier case we have a minus pi by 4 as an angle, but in this case we have plus pi by 4 as a angle. We have same amplitude either in this case or this case. Okay, so we have a same amplitude either in both the cases. So I hope you have understood this. Now this is 13.8. A spring balance has a scale that reads from 0 to 50 kg and the length of the scale is 20 centimeter. A body suspended from this balance when displaced and released oscillate with the time period of a 0.6 second. What is the weight of the body? So let us see the condition. So let us see, this is a spring balance system. Okay, and when you put the mass of a maximum 50 kg, so its stretch is how much? 20 centimeter. Okay, so it means that the amplitude maximum displacement or the maximum displacement is amplitude is 20 centimeter or it is 0.2 2 meter. It is 0.2 meter. Okay, now they have also provided time period as a 0.6 second. Okay, what they want? What is the weight of the body when the what is the weight of the body when there is an oscillation of the time period of a 0.6 second? Okay, so we have maximum weight as how much? Or maximum mass is 50. After that it won't read, so this is 50 kg. Maximum displacement of the spring is how much? Maximum displacement, that is equal to 0.2 meter. Maximum force or maximum weight exerted, maximum force is equal to mg, that is equal to 50 into 9.8, so this will be 490 newton. Got it? Now from here we can find a spring constant. So spring constant, that is k is equal to force by length, and this is equal to 490 divided by length is how much? Length is 0.2. So from here we can get 2450 Newton per meter. We have got the spring constant. Now we know that time period is equal to 2 pi root under m by a. Basically what happens, if 50 kg is the mass, then what will happen? Maximum displacement will be 20, and for this there will be different time period. Now they have given for time period of 0.67 what was the weight. Okay, so we need to find, so 0.6, this is equal to 2 pi root under m mass we want, k is 2450. So from here mass is equal to 0.6 whole square into 2450 divided by 2 pi whole square. So from here we can calculate it. So when we will calculate it, so we will get as a 22.36 kg as a mass. And weight of the body, so weight is how much? Weight will be equal to mg, so this will be equal to 22.36 into 9.8. So finally we will get as a weight as 209 219.13 Newton as a weight of the body. So this is what our required answer is. This is our required answer. Okay. So I hope you have understood the condition. Now let us go for a question number 13.9. Okay. So guys, this is question number 13.9. So the question number 13.9, a spring having with the spring constant of 1200 Newton is mounted on a horizontal table. So this is horizontal table and it has been mounted. A mass of 3 kg is attached to the free end of the spring and the mass is then pulled on the side way at a distance of 2 centimeter and released. So let us consider this is the mass and this has been stretched and displaced for 2 centimeter, and now due to this it has been displaced for 2 centimeter and then released. So what will happen? There will be a vibration. So what we need to find? We need to find a frequency. Okay. Before that, what they have given, we should definitely write what they have given. So spring constant they have given as 1200 Newton per meter mounted on a horizontal as shown in a figure, and mass they have given as 3 kg. Okay, as to the spring, and the amplitude, maximum amplitude is 22 centimeter. So it will be 0.02 meter only. Okay, so the maximum amplitude they have given. Okay. Now we know that frequency of the oscillation, that is this frequency is equal to 1 by time period. Now we know that time period is equal to what? Time period is equal to 1 by time period. So time period is equal to 2 pi root under k by m. So time period is equal to 2 pi root under m by k, because it will be omega by 2 pi. So this we need to put here the values. So if you want to put the value, so it will be 1 by 2 pi root under k by m. So k is 1200 divided by 3. So this will be 400. So 400 means 20 by 2 pi. So this will be 10 by pi. This will be 3.18 hertz. This is what required result was for the frequency. Okay. So our frequency is 3.18 hertz. Okay. Now the question is question number 1. This was question number 1. Now question number 2. Now question number 2, it is asking maximum acceleration of the mass. So maximum, we know that A maximum is equal to omega square into amplitude. Omega is what? Omega is equal to root under k by m. So this will be whole square into amplitude is A. So put the value here. So k is 1200 divided by mass is 3 into amplitude. Amplitude means 0.02. This will be 400, so 20 into 0.02. So this will be omega square, right? So I think it will be omega square means 400 only. So it will be 400, not 220. So this will be 400. 400 into 0.02. So this will be 8.00 meter per second square. So this is the acceleration. So our answer for this question is maximum acceleration. So A max, and this is equal to 8.00. So I think I should omit this 00 so that you won't get confusion. So this is 8 meter per second square. Okay. This is what all about question number 2. Now let us do for a question number 3. So in question number 3, maximum speed. So V max is what? V maximum is equal to A into omega. So that is A omega. So amplitude we have 0.02 into omega means what? Root under 12 by 3. So finally 0.02 into it will be 20. So this will be going to be, you will get definitely approximately equal to 0.4 meter per second. So this is the maximum velocity. Okay. So I hope you have understood and the concept of this question. so that you can also able to solve different type of varieties of a question. Okay. Now let us do question number 13.10. In exercise 13.9, let us take the position of the mass when the spring is on stretch as equal to 0, and direction of from the left to right as positive direction of x-axis. Give x as a function of a time for oscillating mass if at the moment we start the stopwatch t is equal to 0, the mass is at a mean position. In what way this function for S.H.M differ? So exactly what we need to do here, we need to find the exact equation. Okay, we need to find the exact equation. Let us take the position of mass like this. So we need to find the x function of a time t. So we need to find x as a function of a time t. Okay, we will do step by step. So first of all, what are the values they have given? We should definitely note down. Okay, so the value in earlier case they have given us spring constant as 1200 meter per second. Mass they have given as 3 kg. Amplitude is given as 0.02 meter. Now we need to find omega. So omega is equal to root under k by m. So this will be root under 1200 divided by 3. So this will be 20 radian per second. So we have got. Now let us consider the general equation is x is equal to a sine omega t plus phi. Okay. Now see here, maximum amplitude won't be changed. X is equal to a. In each and every case, whatever will be the condition, whenever you want to study the motion, the maximum amplitude, that is 0.02, will remain same. Sine angular frequency will also remain same, but what will change? Phi will change. Okay. So here we need to put the in place of omega, we can put here 20t so that we can get the exact values. So this will be 20t plus pi. Okay. So this is what x value. Now first case, we should solve first case. Case number A, that is at mean position. Now at mean position what happens? At mean position what will happen? Try to understand mean position. Whenever a body is moving, either in the form of a spring as well as a body, it is kept in a table. So this is the mean position. So from this x is equal to 0, may go to the maximum one, it may go to the minimum one. Okay, so this is what we need to find. Okay, so at mean position, x will be definitely, the value of x will be equal to 0. So now x is equal to 0 at a time t is equal to 0. At a time t is equal to 0, so we need to put the values here. So we are putting the values. So this will be 0.02 sine time t is equal to 0. This will be 0 plus pi. So from here sine phi is equal to 0. So this will be equal to, it means that phi is equal to 0. So now put the actual formula. If we put the values, each and every values, so what we are going to get, so x is equal to 0.0 sine 20t plus pi. So this will be the general formula. This is what we have got for the case of A. Now we will discuss for the case of B. Now we will discuss for the case of B. So let us discuss for the case of a B. In case B, at maximum stage position, at maximum staged position. So if we talk about the at the maximum staged position, so what will happen at maximum stage position? The value of x will be 0.02. So now we need to put the value. This will be x is equal to 0.02. This is equal to 0.02. See, x is equal to 0.02 at a time t is equal to 0, right? So we have to put the each and every value. So sine 20 into time t is equal to 0. So plus pi. So this will be 1 is equal to sine pi. So from here, phi will be equal to pi by 2 only. So we need to put the values now. So if we put the values, so we will get x as the 0.02 sine 20t plus pi by 2. So this is our desired result, right? This is our desired result for this question. So this will be 20t plus pi by 2. I hope you have understood now. Now let us discuss for the question next part, that is C. In C they are talking about the maximum compressed position or maximum compressed position, right? Compressed position. So basically what you are doing, if you have a spring mass system and this is a mean position, when you compress, so this will go to the this side. So extreme, this will be only extreme mean position only. This will be extreme position only. So this will be 0. This will be 0.02 meter, and this side also there is a 0.02 meter. I hope you have understood now. Now for a maximum extreme compressed position, x will be equal to minus 0.02 at a time t is equal to 0. Now we need to put the values there. So x is equal to minus 0.02. This is equal to the equation what we have used is equal to 0.02 into sine omega t. So t is equal to 0. So this will be 0 plus pi. So this will be minus 1 is equal to sine phi. So from here sine phi is equal to minus 1. So we may get the value of sine phi is equal to minus 1, means phi, we have a high values. High values. So phi value will be equal to 3 pi by 2. Now we can put the values. The value, so x is equal to minus 0 point. So why should I put here minus? So we should put here as it is. So this is 0.02 sine 20t. It is not omega t, it is 20t. Okay, sine 20t. So we need to put here sine 20t plus pi. So pi in place of pi, have to put here 3 pi by 2. 3 pi by 2. So this is our desired equation for this case. Hope you have understood this. Okay. Now this is question number 3.11. In 3.11, figure 13.20 correspond to the two circular motions. The radius of the circle, the period of the revolution and initial position, and the sense of revolution, that is clockwise or anti-clockwise, are indicated on each. Obtain the corresponding simple harmonic motion of x projection of the radius vector of the revolving particle in each case. So first of all, we can solve this case. So let us consider there is a one particle. this is one particle, okay, and it is moving in this direction. So the it has moved, angle it has moved is equal to theta. Now the theta is equal to omega t. Theta is equal to omega t here. Theta t is equal to omega t, right? We need to find the corresponding this one, corresponding projection length. So before that, we need to find x is equal to, as we know that x the equation we can find, then we will get the value of x. So x will be equal to what? So actually we need to find here value of x. So how you will find? So if you see this as a triangle, so what you are observing, so this angle was theta. So definitely this, now this will be 90 minus theta. This will be 90 minus theta. So what will be this length? This length they have given us 3 centimeter because the radius is 3 centimeter. So this will be how much? So this length will be t cos theta. Okay, so basically x is equal to 3 cos theta is there. Theta is known as omega t. So basically what happened, we can write here 3 cos omega t. Now we need to put the value of omega. So we know we have a time period as a t is equal to 2 seconds. So omega will be equal to 2 pi by t. So this will be pi only. Why? Because time is equal to t. So finally x is equal to 3 cos pi into t. So this is the desired equation we required. Okay. But one thing, one I think there is a problem. What problem we have done here? There is a mistake I've done is that this is not a cos theta. Why it is not cos theta? Let me try to explain you. Let me try to explain you. See here. This is the triangle. So this is the angle theta. This is angle theta. This is triangle. Okay. This is angle theta. So basically this will be 90 minus theta. So this will be sine theta, x sine theta, if it is your x. So basically we have to use here not 3 cos theta. We have to use here 3 sine theta. Okay. So here we can use 3 sine theta. So 3 sine omega t. Now omega has a value pi. It will be 3 sine pi t. But one thing what we have done, see here, since it is moving in this direction, so x body is moving in this direction, so the x will be negative. So the value will be minus only. The value will be minus. Okay. So finally our desired result was minus 3 sine pi t centimeter. Okay. Now see here, in the second case, what we need to, in second case, let the object is present at this point. So if the object is present at this point and is like this, So its projection is this one. So this is your x projection. So see, it is moving from this direction. So it means this is angle theta. So this will be x is equal to cos x. This x length is equal to, see, radius is 2 meter. 2 meter, right? So the radius they have given 2 meter. So this will be 2 cos theta. So finally our result will be x is equal to 2 cos theta, and since it is negative, so we have to put here negative because it is in the direction of negative x-axis. So here we can also put 2 cos theta. In place of theta it is omega t. So x is equal to minus 2 cos omega t. Now we need to find omega. So omega is equal to 2 pi by t. So here time period is 4 centimeter 4 seconds. So this will be 2 by 4 pi. So this will be 0.5 pi. So from here x is equal to minus 2 cos omega t by 2 we can write here. This is our required result for this equation. Okay. So this is our corresponding simple harmonic motions. Okay. So these two motions we have got. This is in centimeter. So we can write here in centimeter. Now here it is saying question, it is saying what the corresponding reference circle for each of the following simple harmonic indicate its initial time t is equal to 0, position of the particle, the radius of the circle, and angular speed of rotating particle. For simplicity, the sense of rotation may be fixed as anti-clockwise in every case. So we need to find out the same circle as we have done this. So this type of circle we have to draw for each equation. So we have to take first of all equation A. So I will work on the equation A only. So let us do for equation A. So equation A, equation for A, x is equal to minus 2 sine dt plus pi by 3. Okay. So let us make a reference circle for this. So I have made a reference circle like this. So this is a straight line like this, straight line like this, and there is a circle. I am making the circle from blue color like, okay. Okay. Now what they have given, and time t is equal to 0, time t is equal to 0, what will be the value of x? So x value will be equal to minus 2 into sine pi by 3. So sine pi by 3 means sine 60. So sine 60 will be root 3 by 2. Okay. Sine 60 will be equal to root 3 by 2. So minus 2 into root 3 by 2. So 2 to get out, get cancel out. So finally minus root 3. So root 3 minus. Okay. Since maximum amplitude is 2 centimeter 2, so the radius of the circle is radius is 2 centimeter. Okay, because the maximum amplitude is 2. Okay. Now the corresponding x value is minus 3. So minus 3, so this is x, this is y, this is negative direction, this is positive direction. Okay. So from here, definitely it will be less than minus 3 means minus 1.73. So definitely it is less than 2. So this there will be a point. This is the point where the position or the projection of any two position has been projected for the spherical surface. So from here we can see that just think about the reverse case. Earlier what happened? We have considered this position and we have got the projection. Now in this case we have got the projection, but we need to find the position. The position will be either this one or either this one. Okay, so there are two cases, and it is moving in anti-clockwise direction. So it will be this direction or there will be in this direction. Okay, so how you will detect that which is the perfect position? So for that we need to find the velocity. So if we need to find the velocity, so velocity for a time t is equal to differentiation of x. This will be minus 2 into 3 sine, not sine because differentiation of sine will be cos. So this will be cos 3t plus pi by 3. Now at a time t is equal to 0, if we put that velocity at a time t is equal to, so if we put this, so what we will get? Minus 6 cos pi by 3. So cos pi by 3 means 60. So this half. So this will be minus 3 centimeter per second. So it is negative. So negative means what? In which case you think that it is moving in negative direction? Definitely from above, we can infer that from the above that this is moving in negative direction of x-axis and this is moving toward positive direction. So definitely our correct answer will be this one. Okay. So the correct position for this is this one. Okay. This one is the correct position. Okay. Correct position. I hope you have understood now how to make the reference circle of this displacement curve. Now we will do same for next curve, that is question number B. That is x is equal to cos pi by 6 minus t. So if we rearrange the equation, so we have x is equal to 1 cos t minus t plus pi by 6. Or we may not simplify it, just we can write as it is. So now at a t is equal to 0, the value of x will be equal to cos pi by 6, cos that is root 3 by 2, root 3 by 2. Okay, so it is positive 1. Now let us make a reference circle here. So let us make a reference circle. This is the reference circle. Okay, now the radius, from here we can infer that the maximum amplitude a is equal to 1, the radius will be equal to 1. So this is the circle with the radius is equal to 1. Okay, now let us consider here, if the circle with the radius is equal to 1, now the value of x, so x is equal to root 3 by 2, that is 173, 1 by 2. So this is approximately equal to 0.8, approximately 0.8, and it is positive value. So somewhere it will be at somewhere at this point. Now the thing is that it is the projection, but where is the position? So position of this will be maybe at this point or maybe at this point, because it has two possibility. Now the actual movement is in this direction and this direction. Now we have to find the velocity. So if we will find the velocity, so velocity v is equal to cos. So differentiation of cos is equal to minus sine. So minus, and it is the coefficient is minus. So minus minus will get plus, so sine sine pi by 6. It will be sine velocity. If you will differentiate it, so this will be minus of minus sine pi by 6 minus t. So this will be sine pi by 6 minus t. Now at a time t is equal to 0, so we will have a sine pi by 6. So pi by 6 means sine 30. Sine 30 means 1 by 2. So this is positive one. So positive means 1 means what? Positive 1 means, see, this is positive 1. So positive 1 means what? See, this is going toward positive and it is going toward negative. So definitely from above we can say that the position of the particle is this one and this is wrong position. So this is the correct position. Okay. This is a reference correct one. This is the reference circle for the equation number B. Now let us discuss same equation for C. So the equation for C is x is equal to 3 sine 2 pi t plus pi by 4. Now at a time t is equal to 0, before that we have to make a reference circle having a radius of 3 centimeter because it's a amplitude, maximum amplitude is 3, so we have to make a circle having a radius of 3. So I have made here a circle with a radius of 3 centimeter. Now we need to find at t is equal to 0 x, value of x. So x will be equal to 3 sine pi by 4. Sine pi by 4 means root 2. So it will be 3. Yeah, 3 into 1 by root 2. So this will be 3 by root 2. So this is positive one. So definitely our value will definitely lie in 3 by root 2. It may happens at this point. But what are the position? So this is the projection. So what are the position? Possible projections. So possible projection may be at this point and maybe at this point. Okay. So which point? So we have to find ultimately our sense is in anti-clockwise direction. So it is going in this direction and it is going in this direction. So finally, velocity. So if we want to calculate velocity, velocity is equal to 3 sine 3 into, we differentiate this equation. So this will be 3 into sine pi t. This will be 2 pi sine differentiation. It will be cos into 2 pi t plus pi by 4. Okay. So this will be 6 pi into cos 2 pi t plus pi by 4. Okay. Now at a time t is equal to 0, so we have to put 6 pi cos pi by 4 into cos pi by 4. So the value, if we calculate the value, so we will get positive. Positive means which one is going in positive direction. So this one is going positive in a positive direction. So the perfect position for this is this one, and this is not the position. So this is the required result for this question. Now let us go for question number D. And question number D, it is D. It is given x is equal to 2 cos pi t. The amplitude or a radius is equal to 2. So we can make the circle like this, and circle having a radius of 2 centimeter. Now at a time x at a time t is equal to 0, what is the values? X at a time t is equal to 0, what is the value? So this will be cos 0. So cos 0 is 1. So 2 cos 0. So this will be 2. So it means that the radius is also 2 and this is also 2. This is the extreme position. So the position of the particle is at extreme position. In extreme position, no direction is required. No direction is required. Why? Because we don't have any option. So it is at an extreme position. So this is the required. I hope you have understood this question. Anyway, Hope you have enjoyed this class, and hope I will also complete next questions of this chapter for this in the next part. So for now, it's sufficient, and thank you for watching my video.